everyone and welcome to class of security mechanisms in TETRA networks. So today in our class we are going to discuss about different security mechanisms. Now first is identity here in this. Each piece of terminal includes a unique identifier, TETRA equipment identity. The terminal equipment has assigned ITSI, which is individual terminal subscriber identity. This is basically the terminal phone number. It may also be programmed with one or more group identifiers or GSSIs, which are group short subscriber identity. We have mutual authentication over the air, OTA as over the air interface. The TETRA standard supports the mutual authentication of a mobile station on one hand and network. Network, which is SWMI, it stands for Switching and Management Infrastructure. This makes it possible for a TETRA system to control the access to it and for a mobile station to check if a network can be trusted or not. In TETRA, the authentication is a basis for overall security. So we require to ensure a correct billing in public access system. There should be control the access of a mobile station to a network and its services, and we require to derive a unique session encryption key, that means the derived cipher key, which is linked to the authentication and establish other security parameters. So this is indirect mode operation. Use of static cipher key can provide a mutual authentication. This is authentication key K and this is the network authentication center. Check, this is a genuine, this is a real network. Both require to authenticate themselves. So mutual authentication is done on the basis of authentication key K, which is a unique for every mobile station or subscriber identification module SIM. This K is stored in both mobile station and in the network. With network we call it as authentication center. The derived cipher key is a unique encrypted key or encryption key which is used to encrypt information. The static cipher key is a fixed pre-stored encryption key which is used to encrypt information. Next we have encryption. As the air interface, it is very vulnerable to attacks. So we have air interface encryption. The air interface security is intended to secure the communication. It is an effective means to provide security in a mobile network, and some essential security function can be realized only with this. Air interface security between the mobile station and the network. This is between these two and end-to-end security. The air interface encryption, it is available for voice data and direct mode operation. Use of several algorithm both standard and the property is supported in this. Next we have end-to-end encryption. The TETRA end-to-end service can be realized in a number of public safety organizations. They have national security requirements for implementation of end-to-end encryption. It will be different from security of military user groups which have a greater security requirements. It has anonymity. That means it is possible to make this encryption dynamic in the sense that an identity is encrypted in a different way on different occasions. It is available for voice, data and DMO. Next is it can be achieved by SWMI assigning temporary individual or group identities and then encrypting these over the air interface. Secure enabling and disabling of terminals. TETRA supports different options for a direct secure disabling and enabling of terminals. The mobile equipment based on TEI, which is terminal equipment identity. If it is disabled, the MS can't be used anymore. If ITSI is disabled on MS, it can still be used in combination with another one. So these are some of the credentials. Thank you.